Hello and welcome back to a video series on MAT 1033 Intermediate Algebra. My name's Sean Perry. This is video number 32 in the series, Solving Radical Equations. So before we begin on solving species of radical equations, let's remember about the basics of solving linear equations. Let's take as an example this one, 3u plus 1 equals minus 2u plus 6. And remember, when we're solving for a variable, our goal is to isolate that variable, which means to get it alone on one side of the equal sign. Now, the first thing we want to do is group our like terms together so that there's just a single u. Sometimes I combine that with this next step, but we can also do it separately. Now we want to start at the bottom of PEMDAS and move this dangling plus 1 over to the other side, so that the only thing on the left-hand side is a u term, along with its coefficient, and we've moved this 1 from one side to the other as a minus 1. 6 minus 1 gives us 5. Then we move up from addition subtraction to multiplication division on PEMDAS to get rid of our coefficient of u. We divide by 5, just like this is multiplying by 5, and using inverse operations, we get the u by itself, times 1, which we just write as u, and this is equal to 1. Now, radical equations are going to go up one more step in this process. Remember, radicals are just fractional exponents, so it's not too much of a surprise that we're going to work with them at this E level of PEMDAS. In fact, maybe it should be called PERMDAS, just because radicals are another kind of exponent, but in any case, let's continue. Now, radical equations have many different things you can do with them. You can put radicals inside of radicals. You could have them of different indices on both sides, and these require some pretty fancy tricks. We are going to look at a simpler kind of radical equation. We're going to look at a radical equation that is a lone radical equation with maybe some multiplication and addition going on the outside, and maybe some multiplication and addition going on the inside. So here, A, B, C, D, E, and F are all just numbers, and we're going to do only radicals that have C as a positive integer. There's also powers of X that we could apply to this. In any case, if you make this equation more complicated, if it gets trickier, we're going to need additional tricks. One thing that will come later is we're going to add x's to the outside of the radical, and this would require us to use some polynomial methods, and we haven't covered those yet, so that will come soon. As it is, this kind of simplified example still gives us plenty to talk about, so let's look at an example of one. Now, the main idea here is we want to isolate this purple term. We want to isolate the radical itself so that we can get rid of it by using inverse operations. So starting on the bottom here with any addition and subtraction outside of the radical, here we have a plus 3, I minus 3 from both sides to get rid of it. Now we get rid of its coefficient, which is a 2, by dividing by 2 on both sides. This moves us up to the multiplication division level of PEMDAS. Remember, we work up the PEMDAS ladder when we solve. We work down the ladder when we evaluate. So after dividing that off, it looks like this. This is what we mean by isolating the radical. The radical is now the lone term on the left-hand side. And the way we get rid of a cube root is by cubing the radical. So if it's a 1/3 power, we take the third power and composition will cancel to the power of 1. This gets rid of the radical. In order to do that, you just have to raise each side to the third power. And in general, whatever this index is in this position, you want to raise both sides to that power to cancel it. This leaves us with just what was inside the radical in the first place, the so-called radicand. Now, the radicand is kind of trapped by this radical symbol. We need to get rid of the radical symbol before we can solve the radicand part. Now, that kind of makes it like a parentheses, right? The radical sort of trapped this internal part in its own little cluster, which is what parentheses do. And when you get to a parentheses now, we want to start over again and say, are there any addition or subtraction terms? So we begin with this minus 6. Getting rid of that, we add 6 to both sides. And this gives us 1/2 x is equal to 14. Dividing by 1/2, which is of course the same thing as multiplying by 2, we get x is equal to 28. Now, did this process work? Is 28 a solution to this equation? Well, if you ever want to know if you found a solution, what you should do is plug it in, evaluate it, and see if you get a true statement. So now PEMDAS is going to work in the other direction. We work at the deepest parentheses, which in this case is the radicand. We evaluate that first. 1/2 of 28 is 14. 14 minus 6 is 8. The cube root of 8 is 2. And then we do 2 times 2 is 4, and 4 plus 3 is 7. And yeah, that works. 4 plus 3 is indeed 7. So we have a true statement, and this was a solution. Now the question comes up, does this always work? Have we done anything which will only work sometimes? And unfortunately, the answer is no, this does not always work. Now, why doesn't it work? The reason it doesn't work is because sometimes if we square something or take any even power of a negative, we get a positive number. But then taking the principal root of that positive number, we get another positive back. We don't get what we started with, which was -2 in this case. Now, this ambiguity can return what we call extraneous solutions to the problem. Things that look like solutions, but they really don't work because these aren't truly full inverses of each other. We looked earlier at how the square root and the square aren't really full inverses of each other, and in general, this is true for any even radical. That is to say, any radical with an even index. By the powers and roots are not full inverses of each other, we mean they don't cancel perfectly. We will, in general, when solving, get answers that might not work. Here is an example of one. Where is the square root of x plus 1 equal to -2? Now, you could graph this and see that it is simply never equal to -2. In fact, before we begin this example, maybe now is a good time to look at the graphs of radical equations just briefly to see why some of these equations aren't going to work out. Remember, if you want to know more about a certain kind of equation, it's sometimes helpful to graph it. Let's see what y equals the square root of x looks like. Now, notice that it seems to stop right here at 0. It has a positive branch here. And what it isn't doing is completely canceling the square itself. We talked in our inverse functions lesson about how that would imply it was a reflection over this green line, but we can see there's no branch down here. That branch would have been filled by negative square root of x, but the positive square root alone, what we call the principal root, is just this red branch here. If you can understand this picture, you'll understand why the blue and red line are not full inverses of each other. Let's take a look at some more powers of x, specifically some fractional exponents. Let's look at the 1/2 power. Here you can see, because it covers up the red line completely, that the 1/2 power is just the square root. Now, let's consider the 1/4 power, or the 1/6. Notice that they have a similar look to the 1/2 power. But what about the third root? Oh, well, that's a little different, isn't it? Yes, it's even defined for negatives, or rather, it gives us a real number for negative inputs. So this is a bit different of a situation. Consider how that relates to the cube root. They are indeed reflections of each other, and indeed, the third power and the cube root are full inverses of each other. So odd powers aren't really going to give the same problem that even powers do when we go to solve. So now let's consider the problem at hand. Let's consider the square root of x plus 1. And where is that equal to -2? Well, just a quick little glance here will let you know it isn't. There are no values. It stops right here. It doesn't branch down here. It is not equal to -2. So this isn't a real question in the sense that it's not going to have a good answer. Now, positive values are going to give us an answer, but something about this is not going to be true for negative values. Let's go back to the notes and see algebraically why this might be the case. So what we would do first is try to square both sides. In squaring both sides, we'd get rid of our radical, but over here, this would become a 4. Subtracting 1 from both sides, I'd get x equals 3. And it doesn't really feel like anything's gone wrong yet until we try to plug in 3. Now, the square root of 3 plus 1 is the square root of 4, which is +2, and not -2. So it didn't work. And we saw why graphically just a moment ago, but this is why algebraically. Now, this gives us a certain takeaway. The takeaway here is that when you solve radical equations, and I would do it for all of them, just as good practice, but this is really going to apply for radical equations with even indexes. You have to plug in your answer. You can't just solve it and hope that your answers will be correct. This is not a skippable step. So that brings us to our critical notes. Copy these down to prove you watched the video. Show them to me later. First, to solve radical equations of the kind that we're concerned with, you want to first isolate the radical. Use inverse operations to make this radical the only thing on one side. Then, raise both sides to the power of this index. Remember, if you don't see an index, it's a square root, and you should raise it to the second power. Once you do that, the radical will disappear, and you use the inverse operations we're familiar with to solve the rest of it. Now, you must check your answer when you are done. That's how you would solve these equations. Okay, here's some praxis exercises for today. I want you to try these on your own. Pause the video at this time, and give them a shot. Okay, let's see how you did. So the first one says the fourth root of x minus 5 is equal to minus 2. Adding 5 to both sides, we get that the fourth root is equal to 3. Raising each side to the fourth power, I get x is equal to 81. Does this work? Plug in 81. The fourth root of 81 is 3, and 3 minus 5 is indeed negative 2. So this worked. What about number 2? So now we have some more numbers. First, we want to get down to this radical by inverse operations. We begin with the lowest, which is plus 1. We minus 1 from both sides to cancel. This gives us that 2/3, the third root of 4 minus 2x is equal to 2. Now, if we divide by 2/3 on both sides, that means multiplying by 3/2, which gives us 3. So this tells us that the cube root of 4 minus 2x is equal to 3. Raising both sides to the third power, we'll get rid of this third root, and that just gives us our radicand, 4 minus 2x. This is equal now to 3 to the third power, which is 27. Minus 4 from both sides to get rid of this positive 4, and divide by minus 2 on both sides to get rid of this minus 2 timesing the x. This gives us the fraction negative 23 over 2. Is that correct? Only one way to find out. Let's plug it back into the equation. So we replace x with that. Negative 2 times negative 23 over 2 is positive 23. And 4 plus positive 23 is 27. The cube root of 27, or the thing multiplied by itself 3 times, 3 times 3 times 3 is 27. So that means the cube root of 27 is 3. 2/3 of that is 2. And 2 plus 1 is indeed 3. Huzzah! This worked, actually. So negative 23 over 2 was the answer. Finally, let's take a look at the square root of 2x plus 1 plus 6 is equal to 3. Minusing 6 from both sides, we get the square root is equal to negative 3. Squaring both sides to get rid of the square root, we get the radicand 2x plus 1 is equal to negative 3 squared, which is 9. Minusing 1 from both sides, we get 2x is equal to 8. And dividing by 2 on both sides, we get that x is equal to 4. The question is, does that work? Is the square root of 2 times 4 plus 1 plus 6 equal to 3? Question mark. Well, let's work it out. 2 times 4 is 8. 8 plus 1 is 9. Square root of 9 is 3, and 3 plus 6 is 9, which is not 3. Okay, so no, it didn't work, and we have to throw out that answer. That means if they asked you for an answer at this point, you would say no solution. We would use the empty set in this case. This means the question that has been asked does not have a correct answer. All right, that's it for this video. There will be more on solving radical equations of a slightly more difficult species later on in the course. But for right now, this is all I want you to know. Thank you for your patience. Have a great day and good luck with your studies. I will see you in the next one.